Remember our students and enrolled relations, where students relation had attributes SID for student ID, name, age, GPA, and enrolled relation had attributes SCID for student ID, CID for course ID, and grade. We sometimes may need to use queries like select everything from a student's S and enrolled E, where S.SID equals E.STID. This query can be expressed in relational algebra using the join operation, which is one of the most useful operations in relational algebra. We may also write down our SQL queries with join operations, putting tables together in specific conditions to select related data. Join can be defined as a cross product followed by a selection expressing the condition, and a projection reducing among the common attributes, for example, a natural join. However, the result of a cross product is usually a very larger table than the join. Therefore, there are algorithms for join trying to avoid the use of cross product as a part of join. In this section, we will start discussion with nested loop join, which basically works based on cross product. Then we will discuss block nested loop join and indexed nested loop join, which apply the partitioning and indexing techniques to avoid enumerating the cross product. Then we will discuss merge join and hash join that take advantage of join conditions in partitioning. Then we will discuss the cost of each algorithm and how it affects our choice of the join algorithm. Assume the general case of theta join of two relations R and S. The simplest join algorithm, which is the nested loop algorithm, evaluates one tuple at a time in a nested loop and tests the join condition on each combination of tuples from R and S within this nested loop. It scans the entire inner relation S for each tuple R in the outer relation R. This is called nested loop semantics. Basically, we are interpreting what a join means using a nested loop, implementing the cross product of two relations, and testing the theta condition on every resulting tuple. What is the cost of a nested loop join? Assume we have m pages in relation R, each page containing PR tuples. Also, assume we have n pages in relation S, each page with PS tuples. A quick reminder here that we are considering cost in terms of I/O operations. Since relation R has m pages, the cost of scanning the relation R will be m I/O operations. And since relation S has n pages, the cost of scanning the relation S will be n I/O operations. Within the nested loops, we scan the relation S one time for every tuple in relation R. Therefore, we scan it for a total of m times PR number of times. This means n times m times PR I/O operations are involved. Summing up this with the number of I/O operations for relation R will result in our total cost, which is m plus n times m times PR. How do you feel about this number? Let's go back to our initial example, the students and enrolled relations. Assume we choose R to be our students table with 1,000 pages and 100 tuples per page, and S to be our enrolled table with 500 pages, and we don't have the number of tuples per page. The cost of our join operation will be 1,000, which is m, plus m times n times PR, which is 5 times 10 to the power of 7. This is huge. Is there any way to reduce it? In this implementation, yes. Since we know we will retrieve all the tuples in S in the inner loop, one simple thing we can do to reduce the cost is to retrieve the tuples one page at a time. This is simple. And this simple change will improve the cost by eliminating PR from the product of the second term, therefore reducing it 100 times for this example.